Hi friends, good morning. Welcome back to ASTRA 2022 program presented by AKKA IAS Academy. In this particular video, I'll be discussing about the basic concepts based upon permutation and combination. So guys, let's begin. This video is going to be quite long guys because the concepts based upon permutation and combinations are actually lengthy. So permutation and combination. So permutations and combinations, okay. And in the next video, while solving these problems, I'll also be dealing with the formula as well as the short trick method. But actually, if at all you know the formula method, it's going to be easy for you. So I'll discuss in this particular video the formula method and how the concept works, okay. See here, actually in this permutation and combination topic, you'll be expecting the problems based upon words and numbers mainly, okay, mainly words and numbers, okay. So then what is permutation and what is combination, okay. Both are different guys. Actually give attention here. I'll take up an example and I'll explain you guys, okay. See here, consider there are three balls, okay. Consider there are three balls, ball number 1, ball number 2 and ball number 3. So there are three balls, okay. So what is your target is, what is the question is, pick two balls at a random, okay. Question is to pick two balls at random. So out of these three balls, if at all we ask you to pick two balls at a random, then in how many ways you will be picking the balls, okay. In first condition, either you may pick ball number 1 or ball number 2, yes or no. In the second type, you have the options of ball number 2 and ball number 3, and in the third option you will be having ball number 3 and ball number 1. These are the different types you may able to pick the balls here, okay. So this is known as combination, okay. Combination, okay. See, out of these three balls, you have picked two balls in three different manner, okay. Either 1 or 2 or 2 or 3 or 3 or 1, okay. This type of picking what we have done, this is known as combination, okay. See here, I'll explain you with an example. The second type of picking what you can do here is, see here, if at all there are two positions and you need to place these three balls, okay. See here, if at all there are two positions, position A and position B, okay. See, in these positions, if at all they are asking you to place these two balls, okay, place two balls out of these three balls. How many balls were there initially? There are three balls, first ball, second ball and third ball, okay. Now in the earlier question, just they have asked you to pick two balls randomly, okay. But in this question, there are two positions, position A and position B. So in this position, if at all they ask you to place place two balls out of these three balls, see what you will be doing here is, either you will be placing first ball in the A position and second ball in the B position. See here, one condition, or else second ball in the first position, A position, and first ball in the B position. See the difference you are making, the difference you got to know right here. In the earlier case it was 1 and 2 only, because they are asking you to pick the ball randomly, okay. They are not specifying the position or something like that, okay. But here in this case specifically they are telling that you need to place two balls out of three balls in a particular position, okay, in A and B. For example sake I'm telling you here, okay. So what is the third case then? 2 or 3, or third ball or second ball, okay. Then first ball and third ball, and third ball and first ball. So how many ways you have done here? 1 2 3 4 5 6. So there are 6 different ways here, okay. There are 6 different ways you could place two balls out of three balls in position A and position B. See here, whenever the possibilities, okay, See, these are the possibilities, right? When you compare these two conditions here, see, when you compare the above condition as well as the second condition, these are the possibilities, right? What are the possibilities? Possibilities of picking 2 ball out of 3 balls. Okay, there are two kinds of possibilities here. Okay, so if at all, see here, if at all the possibilities are taken into consideration, see here, mind the words here. Okay, all the possibilities are taken into consideration, then that is known as permutation. Then this is known as permutation. If at all only required possibilities are taken, okay, if at all only required possibilities are taken, then this is known as combination. Okay, this is the definition of permutation and combination. You need not remember any definition, but you need to understand how the concepts work. Okay, based upon the questions. So if at all the question asks for permutation, then this concept, the second concept works. If at all the question asks for combination, the above concepts works. Okay, see here, what is the formula for permutation? Then formula for permutation is NPR will be equals to n factorial upon n minus r factorial, whereas the formula for combination is, pay attention guys here, NCR will be equals to n factorial upon n minus r factorial into r factorial. Okay, this formula you need to by heart. Okay, this formula you need to by heart, these two formula, permutation formula as well as combination formula. Okay, so friends, in the next page I'll be taking an example and I'll explain you how how you'll encounter problems in the examination and how you need to tackle it. Okay, see here, if at all the question asks, okay, in how many ways the words can be arranged. Okay, consider this as type 1 problem. Okay, type 1 problem. In these kind of problems, the question may occurs that how many ways the words can be arranged. The words can be arranged. Okay, see, I'll take an example here. Okay, if at all the word is cat, okay, if at all the word is cat here, CAT, this is the word they have given, and the question is in how many different ways the words can be arranged here. Okay, so if at all you encounter the question based upon words, okay, there are other two concepts. Okay, non-repeated words and repeated words. Okay, so this is the case of non-repeated word. Okay, because no other words have been repeated twice here, so cat is the case of non-repeated word. Okay, see here, cat can be arranged, the word cat can be arranged like this. Okay, CAT, I can write it here, or else CTA. Okay, or else ATC, yes or no, or ACT, or TAC, yes or no, and TCA. Okay, so in these many different ways I can arrange the 3-letter word cat here. Okay, how many ways over? First, second, third, fourth, fifth and sixth. So in total 6 different ways this cat word can be arranged here. Okay, so this is a small letter. Okay, cat, this is a small letter word, so you can write and you can work out the problem here. If at all you encounter a bigger word, okay, there are at least 10 to 11 words in the in particular word, there are at least 10 to 11 letters in that particular word, then solving like this in the conventional method becomes a bit difficult for you. Okay, so actually how the formula works is CAT. Okay, how many words are there? Actually this is a single word. How many letters are there? 3 letters are there, yes or no? 3 letters are there. The formula goes like this: 3 factorial, that is nothing but 3 into 2 into 1. 3 factorial means that is 6. So in 6 different ways this 3 letter can be written, yes or no? Simple. One more example I'll take it here. If at all the word is machine, MACHINE, okay, how many letters are there? 1 2 3 4 5 6 7. So answer is 7 factorial. In 7 different ways, in 7 factorial ways, this letter machine can be arranged here. Okay, this was the case for non-repeated letters. If at all the letter repeats in a word, okay, so if at all the repeated letters, so in repeated letters, what is the case here? Repeated letters. Okay, take an example of word sister, SISTER. Okay, in the earlier case, what you did, you counted the number of letters in that particular word. For 1 2 3 4 5 6, so 6 factorial you will be writing here. So upon how many letters are repeating here, you need to count that here. Okay, so S is there and S is there, so S has been used twice in this particular word. Okay, the letter S has been repeated twice in this particular word, so 6 upon 6 factorial by 2 factorial. This is how you write it. Okay, simple, right? So if I'll take one more example here. Okay, I'll take one more example. Percentage. Okay, so how many letters are there? 1 2 3 4 5 6 7 8 9 10. Okay, 10 factorial upon, see, count the number of letters repeated here. Okay, see here, E 1 times, 2 times and 3 times, and R C N T A G. Okay, E has been repeated 3 times, so upon 3 factorial, 10 factorial upon 3 factorial. So this is the case here. Okay, see, if at all there in a particular word, if at all 2 letters have been repeated twice, then what will be the condition here? See, for example, letter LETTER. Okay, how many words are there in total? 1 2 3 4 5 6, so 6 factorial upon, so E has been repeated twice. In the similar case, T has also been repeated twice. Okay, so what is the formula here? So E has been used twice, the letter he has been repeated twice, and T is also used twice. Okay, so 6 upon 2 factorial upon 2 factorial, 2 factorial into 2 factorial. So this is the condition you will be working out here. Okay, so in the next page, see, in type 2, okay, in type 2, how you can expect the question is based upon vowels in the letter. Okay, what are vowels? A, E, I, O, U. These are the vowels. Okay, in a particular word, how many vowels are there, and in how different ways the vowels can be arranged, then that can be grouped together, or it can be occurred in the odd or even places. Okay, that vowels should be particularly in the first place itself, or else in the last place. Okay, these are the different types of questions you can expect here. Okay, vowels can come together, okay, or vowels cannot come together. These are the different types of questions you will be expecting upon the vowels here. Okay, what is the vowels? A, E, I, O, U are the vowels here. Okay, for example, say the letter judge, JUDGE, this is the letter judge here. Okay, so identify the vowels here. Okay, U is the vowel and E is the vowel, so there are two vowels, U and E. There are two vowels here. Okay, see here, whenever this such kind of questions are encountered, see, you need to solve the question on the basis of what I'm dealing with here. Okay, see here, what was the letter actually? JUDGE is the letter. Okay, and the question asks in how many ways the word can be arranged so that the vowels always come together. Okay, the first condition is vowels come together. Yes or no? Consider it, vowels come together. Vowels come together. So what are the vowels here? U and E. So write it separately like this, U and D in a bracket. So what are the remaining letters here? So U over and E over. So J, D, G are the remaining letters here. J, D, G are the three letters remaining here. Okay, so group it like this first for your reference sake. Okay, so then see here, this U and E comes together. This condition has been satisfied. The vowels should come together. Okay, and this U and D can be placed before here. Okay, see here, can be placed here. So U and E, then J, D, G. This can be written like this, yes or no? Or else see here, this U and E either can be it can become here, or else it can come here, or else it can come here. Okay, so there are how many possibilities are there? See here, first possibility, second possibility, third possibility, and four possibilities. So spaces are there 1, 2, 3 and 4. So how many possibilities are there? 4 possibilities are there. So that is 4 factorial. So into this U and E, either it can be written as E or U also. So 2 letters are there. So that can be written in 2 factorial ways. So 4 factorial into 2 factorial. Okay guys, vowels coming together, and in how many different ways the words can be arranged. Okay, the word judge can be arranged so that the vowels are coming together. The answer will be 4 factorial into 2 factorial. See, I request you to solve more and more problems. Okay, then only the efficiency or the proficiency, okay, the proficiency will be increased here. Okay, see here, one more problem I'll take here. Considered a letter machine, MACHINE. Okay, identify the vowels first. So A is there, I is there, and E is there. So how many vowels are there? 3 vowels are there. Those are A, I, E. Okay, so what are the remaining letters then? The remaining letters are M, C, H, N. Okay, so these 3 are together. Okay, these 3 are together. So in this place they can I can write this A, I, E, or this place, or this place, or this place, or this place. So 1, 2, 3, 4, 5. So in 5 different places I can write that. So 5 factorial into how many vowels are there? 3 factorials are there, that can be arranged into 3 factorial. So 5 factorial into 3 factorial is the answer for this. Okay, so similarly when this second condition I'll take here. Okay, the second condition is vowels come together. Okay, in repeated letters, vowels come together if at all the letter is repeated. Vowels come together when in repeated letters. Okay, so remember guys, in the earlier condition when the repeated letters came, I in particularly how I solved that, you remember that. Okay, the same concept will be here. Okay, the same letter I will be taking, SISTER. Okay, so how many vowels are there? I is there, E is there. Okay, 2 vowels are there, write it separately, I and E. Okay, so SSTR. Okay, so 1, 2, 3, 4, 5. Okay, 5 factorial into this I and D can be written into 2 ways. So 2 factorial upon this S and S are repeated 2 times. Okay, so 2 factorial. 5 factorial into 2 factorial into upon 2 factorial. Simple, right? So vowels. Okay, see here, if at all I'll take one more example here. Okay, in repeated letter, say the word be animation. So identify the first vowels. How many are there? A is there, I is there. So A is there, I is there, O is there. Okay, totally 5 vowels are there. 5 vowels are there. So what are those? A, I, N. Okay, A, N. Okay, so what are the remaining words? Write it here. So N is remaining, M is remaining, T is remaining, N is remaining. Okay, how many spaces are there? 1 2 3 4 5. So write it 5 factorial into how many vowels are there? Actually 5 vowels are there, so 5 factorial. Based upon how many repeated letters are there? See here, examine. A is repeated twice, yes or no? So A is repeated twice, as well as then which letter is repeated? Okay, I is repeated twice here. Okay, so A twice, I twice. Okay, then N M T N. Okay, N is repeated twice here, so N is also repeated twice here. Okay, so no other words other than these letters have been repeated in that particular word. So upon what I will be writing here is 2 factorial, 2 factorial, 2 factorial. See here guys, actually don't make the mistakes of multiplying. Okay, 2 into 2 4 and 4 into 2 8, and you will be writing 8 factorial. Okay, so this is the wrong method. For each letter you will be writing 2 factorial, 2 factorial and 2 factorial in the individual cases. That caution you need to take here guys. Okay, in the next page I'll be dealing with in this particular case was vowels coming together. Okay, in the next page I'll be dealing vowels not coming together. Okay, vowels never come together. Vowels never come together. So let us take an example here. Okay, MACHINE. Okay, so identify the words first which are vowels here. So A is vowel, I is vowel, E is vowel. Okay, so A, I, E, these are the vowels. How many vowels are there? 3 vowels are there. Okay, so see here how many ways the words can be arranged so that the vowels never come together here. Okay, so what is the total amount of letter here? 1 2 3 4 5 6 7 here. Okay, see here guys, actually here one concept I need to tell you. See here, vowels not coming together. Okay, observe here one example I'll be taking randomly. Consider there are 500 students. Okay, 500 students are there in a particular class. Okay, in that 500 students, if at all 200 students are passed, 200 students are passed. Okay, then the question asks you to find the number of failed candidates. Okay, what are the number of failed candidates? What you will do? 500 minus 200 will be 300, and these are the number of the failed candidates. What you did here? Total number minus the given past number. Okay, so you'll be arriving this to the answer. Okay, 300 candidates have been failed out of 500 candidates. The same concept you will be applying to this condition here. Okay, so what is the total combination of that particular word? See, this is the total combination of that particular word. In that total combination, if at all vowels come together, what is the condition? Okay, total combinations of the words and vowels come together. Okay, minus if we do, so then the answer will be vowels coming not together. That will be the case here. Okay, so for example, that letter only will take machine. Okay, that particular word I'll be taking machine, MACHINE. So how many letters are there? 1 2 3 4 5 6 7. So 7 factorial ways this letter can be arranged. So this is the total in total how many ways the word machine can be arranged? In 7 factorial ways. Okay, so upon this you need to identify the vowels first. How many vowels are there? A is there, I is there, and E is there. So what are the vowels here? Vowels are 3 are there, so those are A, I and E. Okay, so what we will be doing here is writing the rest of the letters M, C, H, N. Okay, so how many gaps are there? 1 2 3 4 5. So 5 factorial, yes or no, into how many vowels are there? 3 factorial. Are there any repeated letters in this case? No, there are no repeated letters. Okay, If at all repeated letters are there, upon that repeated letter will be taking here. Okay, see here friends, actually what you calculated here is the word machine. Okay, the word machine can be written in 7 factorial ways in total. In that particular word machine, if at all the vowels are grouped together, so 5 factorial into 3 factorial ways it can be written. If at all you subtract this 7 factorial minus 5 factorial into 3 factorial, you will be getting the answer. What is that answer is, the vowels never come together. Yes or no? Simple it is. Actually understand how the concept works. Okay, if at all you don't get in the first go, kindly pause the video and rewatch it, and you'll be able to understand the concepts. Okay, see here one more example I'll take here. Consider the letter same here, SISTER. Okay, so if at all the question asks in how many ways the word sister can be arranged so that vowels never come together, this is the question here. Okay, so how many letters are there? 1 2 3 4 5 6. Okay, in totally 6 factorial ways the letter sister can be arranged. So this is the first point. So in that, now you need to identify the vowels here. Okay, how many vowels are there? I is there, E is there. So vowels are 2 factorial ways. Okay, vowels are 2. So if at all you group together, that is 2 factorial ways. Okay, so then see here, this is second point only. So what are the remaining letters here? S, S, T, R. Okay, so what is the gap here? 1 2 3 4 5. So 5 factorial into 2 factorial upon, so there are repeated letters here, right? This letter S has been repeated twice here. Okay, so S has been repeated twice, so this will be here 2 factorial. This is the condition here. So we have not arrived to the answer here. Okay, this is the second point. So 1 minus 2 will be the answer. Okay, when vowels are never come together, that is nothing but 6 factorial minus 5 factorial into 2 factorial by 2 factorial. This is the answer here. Simple, right? Yes or no? But you need to understand the concept how it works here. Okay, so I'll take one more example here. Okay, see, consider the word corporation. Consider the example corporation, a big letter, right? So how many how many letters are there in this particular word? See here, 1 2 3 4 5 6 7 8 9 10 11. Okay, so first point is 11 factorial. This I got here, right? So now I need to identify the vowels here. Okay, O is there, O is there, A is there, I is there. Also one more O is there. So vowels will be totally 1 2 3 4 5. So vowels will be 5 here. Okay, and repeated letters, that also we need to take here. Okay, there are how many repeated letters we need to identify here. See here, repeated letters will be R is there, R is there, and O is repeated here, and O is repeated here, and also O is repeated here. T. Okay, O is repeated thrice and R is repeated twice. Okay, so I guess no other repeated word. C O P P. No other repeated words here. Okay, so what will be the formula, guys, here? Actually in first point only, 11 factorial upon repeated words are 3 factorial and 2 factorial. See, this is the point 1 here. So in the second condition, vowels shall be grouped together, right? So I'll write once again here, CORPORATION. Okay, so how many vowels are there? O, O, A, I, O. So I'll write the vowels here, O, O, A, I, O. So 5 vowels are there. So what are the remaining letters here? C, R, P, R, T, N. Okay, how many spaces are there? 1 2 3 4 5 6 7. Okay, 7 factorial into how many vowels are there? 1 2 3 4 5 into 5 factorial upon how many repeated letters are there? 3 factorial into 2 factorial. This is second here. Okay, so 1 minus 2, that is nothing but, so 1 minus 2, that will be 11 factorial upon 3 factorial into 2 factorial minus 7 factorial into 5 factorial by 3 factorial into 2 factorial. So this is the answer here. Yes or no? If at all you solve this, you'll be getting the answer here. Okay, see here guys, actually these are the few of the basic concepts what you need to know, how vowels coming together, vowels not coming together and all. See, in the next page I'll deal with a particular question like this. Okay, see, if at all the question asks like this, okay, in how many ways the word can be arranged, so consider there is a word A B C D. Okay, there are four letter word here. Okay, if at all question asks you to place in two positions, okay, there are only two positions are there, and there are four letters are there. Okay, four letters are there. These four letters should be arranged in these two positions itself. Then what is the formula we know here? See here guys, how I'm writing the formula here. NPR, we know that will be equals to n factorial upon n minus r factorial. See, this is the formula I have told you in the earlier slide. Okay, so how I'll substitute this in the formula? See here guys. Okay, NPR, so how many total words are there? That should be taken as 4, that will be n. Permutation of how many positions are there? 2 positions are there. Okay, so 4p2 is the substitution here, 4p2. Yes or no? See here, I'll work it out how you will be writing it here. 4p2, that will be equals to 4 factorial upon 4 minus 2 factorial. That will be equals to 4 factorial upon 4 minus 2 is 2 factorial. Yes or no? Simple here. See, this is the how problem works based upon the formula here. Okay, see here, if at all you consider one more example I'll take here. Okay, there are A, B, C, D, E, F. How many letters are there? Totally 6 letters are there. Okay, 1 2 3 4 5 6. If at all there are 3 positions, in these 3 positions you need to arrange this 6 letter word. Okay, so what is the formula here? NPR, right? So what will be the n? 6 will be the n. 6 permutation. So what will be there? There are 3 different positions. Okay, 6p3. So that will be 6 factorial upon 6 minus 3 factorial. That will be 6 factorial by 6 minus 3 factorial is 3 factorial. Yes or no? The value of n should always be greater and the value of r should always be lesser. You need to take care of this particular thing here. Okay, see, if at all the condition occurs like this, okay, there are in the above two case where I have discussed, there are number of letters are more and the positions where you need to arrange them is lesser. If at all they have given 2 letters, okay, A and B, they have given only 2 letters and there are positions 1 2 3 4. Okay, in such case what you will be doing here? See here, you need not to write here. Okay, this how many total words are there? This is NPR, means in how many total words are there? 2 words are there. Okay, and P, how many positions are there? 4. So writing this way will be wrong here. Okay, so what you will be doing here is NPR will be 4p2. Okay, 4 means total number of positions and 2 here means how many letters are there. Okay, in how many places the 2 letter word can be arranged. So this will be the way you need to solve the question here. Okay, so in the next page one more concept I'll be dealing with here. Okay, vowels come together, vowels never come together, no 2 vowels come together. There are 3 conditions, guys. Okay, what is the first condition? Vowels coming together vowels coming together. What is the second condition? Vowels never come together. Vowels never come together. So what is the third condition? No two vowels, see here, this is actually important, no two vowels come together. Okay, this is very important. These two conditions students will be making confusion here. Okay, in the next page I'll be explaining and showing you the difference, how the concept works. See here guys, I'll take an example word machine. I'll be taking an example machine here. Okay, MACHINE. In this particular example only, I'll take one example and I'll explain all the three methods. Okay, see, consider here, wait one second. So three cases I'll be dealing here. The first case will be vowels come together. Vowels come together. Okay, so how many total vowels are there in this particular letter machine? Identify the vowels first. So that will be A, I, E. So vowels will be 3 here. Yes or no? Vowels will be 3. What are the vowels? A, I, E. What are the remaining words here? M, C, H, N. Okay, what are the spaces? 1, 2, 3, 4, 5. See friends, in these 5 spaces, these vowels, okay, what are the vowels here? I'll be writing here A, I, E. Okay, these should be together. Okay, A, I, E. One example I'll be writing. Okay, there in these 5 spaces, this vowel can be written together. Okay, A, I, E. These are together here, and the rest of the words will be M, C, H, N. Yes or no? You got it right. These vowels are together in this particular way. So in that 1, 2, 3, 4, 5. So in 5 different positions this can be written here, but the vowels are together here. This caution should be taken here. Okay, so what is the second condition here? Second case will be vowels never come together. Vowels never come together. So how many vowels are there? A, I, E is the vowel here. Okay, so what is the remaining letter? M, C, H, N. These are the remaining letters here. Okay, so here how can I write here without vowels coming together? Means observe here, kindly observe here. So how many spaces are there? 1, 2, 3, 4, 5. So in these 5 spaces I need to arrange these 3 vowels. The condition I should take care that the vowels never come together. This is the condition here. Okay, so here see guys, here I'll be writing M, and first vowel I'll be writing here. Okay, A. Yes or no? So then the remaining letter I'll be writing here. Okay, C, H I'll be writing here, and okay, I'll be writing 2 vowels here. Okay, once again I, E. Okay, what is the remaining letter then? M, A, C, H, I, E. So N is the remaining letter here. Okay, see here, observe what I have written here. Okay, the question states vowels never come together. Okay, it means that in out of these 3, there are 3 vowels, right? These 3 vowels should never come together. Not all 3 vowels, okay, are together here, but 2 vowels can be together here. Okay, 2 vowels can be together. Not all 3 vowels should come together. Vowels never come together means the understanding is that there are totally 3 vowels. These 3 vowels should not come together. So it also states that 2 vowels can come together here. Okay, when I deal with the third condition, you'll be getting more clearer. Okay, no two vowels come together. No 2 vowels come together. Okay, so how many vowels are there? A, I, E. These are the 3 vowels here. So what are the remaining letters? M, C, H, N. Okay. So how this no two vowels come together means, okay, no two vowels come together. So how it can be written? For one example, see here, I'll write M, and first vowel I'll write here. Okay. Then C I'll write here, and then the second vowel I'll be taking here, I, and then H I will write here, and the third vowel I will be taking E. Okay, and then then N. Okay, so MACHIEN. Okay, so these are the ways. Here, see, observe these two cases. Observe here, guys. Okay, kindly observe these two cases. What is the difference here? Okay, vowels never come together means out of the total number of vowels found in that particular word, no that amount of vowels should not come together here. Okay, in this particular example there are three vowels. Okay, in second condition there are three vowels here, so no three vowels should be coming together here. Okay, but in the third case, not even two vowels also should come together. All the vowels should be not together here. Okay, they should be placed in a different position here. Then only this condition will be satisfied here. Okay, in the examination most of the students will be making mistakes here only. Okay, in these two conditions, vowel never come together and no two vowels come together, so you need to take proper caution here, guys. Okay guys, these are the few of the basic concepts what you need to know before solving this permutation and combination chapter. Okay, and coming to the question here, coming to the questions in the UPSC preliminary examination. Okay, you can expect at least one question. Okay, maximum to two questions, at least one question based upon this permutation and combination. Regularly this will not be appearing in the question paper, so that this chapter cannot be given up so much of weightage. Knowing this chapter puts you in a better edge than the other students. Okay, thank you guys, thank you for staying such long. If at all you find this video informative, kindly do share and subscribe to our channel AKKA IAS Academy, and also do like and comment in the comment section. It motivates us to bring more quality content. Thank you, God bless you all. All the best for your exam. We shall meet up in the next video.